January 17, 1942. A bitter winter wind cuts across the Pennsylvania rail yard. Steam rises in thick clouds from the blackened chimneys of locomotives, curling into the gray morning sky. Workers in wool coats and leather gloves move with purpose, their boots crunching on frozen ballast. The smell of coal smoke mingles with the sharp tang of iron rails. A Baldwin-built locomotive rests on the track, massive and gleaming, its polished brass fittings stark against soot-streaked metal. Engineers check gauges, adjust valves, and listen to the hiss of pressure building within the boiler. Nearby, freight cars are loaded with crates of ammunition, food, and medical supplies. Soldiers shuffle aboard, clutching parcels, uniforms stiff from the cold. America's railways were already the veins of a nation, but they were slow, creaking under wartime demands. The war overseas had accelerated the need for speed, efficiency, and innovation. Here, in this fog yard, the seeds of transformation are taking shape. Baldwin Locomotive Works is about to push American rail technology into uncharted territory, racing not just against time, but against the necessities of a world at war. The rails are ready, the engines are ready. The question remains, can they meet the moment? By 1940, the United States possessed one of the most extensive rail networks in the world. Over 250,000 miles of track crisscrossed the continent, linking industrial hubs, agricultural regions, and coastal ports. Steel rails, laid decades earlier, had carried the steady flow of freight and passengers for generations. Trains were reliable, but they were slow. The average express passenger service could reach barely 60 miles per hour. Freight trains, loaded with coal, steel, or farm produce, moved even more sluggishly. In peacetime, this was sufficient. In wartime, it was a vulnerability. The European conflict had already demonstrated the strategic importance of rapid transport. Germany's blitzkrieg relied on rail to move tanks, artillery, and troops with precision. Across the Atlantic, American military planners recognized a stark truth. If the United States were to project power overseas, its railways would have to become more than conveyors of commerce. They would need to be instruments of war. Rail companies faced mounting pressure. The Pennsylvania Railroad, once the pride of the eastern seaboard, carried thousands of troops between training camps and ports, straining locomotives built in the 1920s. Union Pacific, servicing the vast western plains, moved food and raw materials to Pacific ports, where shipbuilding and military supply depots were expanding rapidly. Locomotives were pushed to their limits. Boilers overheated, wheels wore down, and schedules slipped. Coal was abundant, but even that resource posed challenges. The larger, faster locomotives needed more fuel. Track maintenance lagged behind demand, and many lines were single-track, requiring meticulous coordination. Delays were inevitable. Military logistics, long accustomed to the flexibility of horse-drawn supply, now demanded precise timing, and the railroad struggled to keep pace. The federal government stepped in, coordinating with the Office of Defense Transportation. Priority shipments were designated, schedules adjusted, and new equipment requested. But manufacturers could not meet the sudden spike in demand with existing designs. Standard locomotives, built for steady commercial speeds and long service life, could not suddenly accelerate to military standards. The solution required innovation, new engines capable of hauling heavier loads at faster speeds, more durable tracks, and precise scheduling systems. Bureaucracy, however, slowed the process. War Department engineers debated specifications. Rail companies lobbied for cost concessions and realistic timelines. Meanwhile, every delay meant slower deployment of troops, supplies, and equipment. Across the nation, factories and shipyards relied on these trains to move their output to ports, yet bottlenecks formed. Trains backed up in yards, freight piles grew, and soldiers waited in freezing stations. Public awareness was limited but growing. Newspapers reported on congested lines, citing railway delays affecting war readiness. Citizens, used to dependable service, were beginning to grasp that the war effort required more than factories and soldiers. It required speed, coordination, and ingenuity across the entire transport network. By late 1941, as the United States teetered on the edge of full-scale involvement, it became clear that conventional locomotives were inadequate. The combination of weight, speed, and wartime pressure created a perfect storm. Without faster, more efficient engines, military operations would be delayed, supply lines strained, and the nation's industrial output rendered less effective. In this climate, innovation was no longer optional. The government looked to American industry's proven leaders, companies capable of building heavy machinery with precision and reliability. Among them, Baldwin Locomotive Works stood out. Established in the 1830s, Baldwin had decades of experience producing steam engines, locomotives, and rail cars. Its reputation for engineering excellence positioned it to answer a question the nation had never asked before. How do you make American railways move at the pace of modern war? As the fog of January 1942 lifted over rail yard from Philadelphia to Chicago, Baldwin's engineers examined boilers, drive wheels, and suspension systems. Every component became a potential lever to increase speed and power. The challenge was enormous. Push the limits of existing technology while ensuring the engines could survive constant heavy loads. And so, America's rail network, already the lifeblood of commerce and military logistics, faced a transformation. A transformation that would test the ingenuity of Baldwin Locomotive Works, the resilience of railroad workers, and the very structure of wartime supply chains. This tension between the slow pace of existing rail systems and the urgent demands of global conflict set the stage for the next wave of innovation, where engineers and laborers would attempt the impossible, to make America's trains faster, stronger, and capable of sustaining the war effort. Baldwin Locomotive Works, headquartered in Philadelphia, had been building locomotives since 1831. By the early 1940s, it was one of the largest and most respected locomotive manufacturers in the world. Its name was synonymous with precision engineering, durability, and innovation. Yet, despite its long history, Baldwin had never faced a challenge quite like the one 1942 demanded, to redesign and produce engines capable of meeting the extreme logistical pressures of a global war. The company's workforce was formidable. Thousands of skilled machinists, boilermakers, draftsmen, and engineers labored across sprawling factories. Every day, they transformed raw steel and iron into massive locomotives. Production lines that had once focused on civilian freight and passenger engines were now being adapted for wartime needs. Designers worked late into the night, calculating stress loads, boiler pressures, and wheel arrangements. Engineers pored over every detail, from the precise balance of drive rods to the optimal angle for high-speed steam flow. Even minor miscalculations could reduce performance or risk catastrophic failure. The U.S. War Department recognized Baldwin's potential and issued contracts for specialized locomotives. Unlike standard engines, these new machines needed to haul heavier freight at greater speeds, often over long distances and under constant pressure. They would transport tanks, artillery, ammunition, and troop contingents to ports and staging areas. Lifelines for an America rapidly mobilizing for overseas conflict. Collaboration was critical. Baldwin worked closely with federal engineers and the Office of Defense Transportation to define specifications. Military planners demanded engines that could maintain 70 to 80 miles per hour under full load, a significant increase over conventional freight locomotives. Durability was equally vital. The engines had to endure continuous operation without frequent maintenance. Baldwin's engineers experimented with larger boilers, higher pressure steam systems, and more efficient wheel arrangements. Innovations such as roller bearings on axles, improved suspension systems, and streamlined bodies were incorporated to reduce friction and increase speed. The human element was just as important as the mechanical. Baldwin's machinists adapted to new processes, working with unprecedented precision under tight deadlines. Training programs were implemented to teach crews how to operate and maintain the faster, heavier engines. Engineers and laborers shared a singular mission: to overcome the technological limitations of the day and deliver engines that could redefine rail transport. Baldwin's efforts were not isolated. Other manufacturers, including Lima Locomotive Works and American Locomotive Company, also contributed to wartime production. Yet Baldwin's experience with large, high-capacity engines gave it a critical advantage. Its locomotives had already proven reliable in civilian service, providing a foundation for accelerated wartime development. The company's leaders understood that the coming months would test both ingenuity and endurance. Every design choice, every decision in the factory had direct consequences for soldiers and supply lines overseas. Government oversight added another layer of complexity. The War Production Board monitored material use, prioritizing steel and coal for military contracts. Baldwin had to balance innovation with resource scarcity. Every boilerplate, every ton of steel was allocated with strategic intent. There was no room for error. Yet this constraint also fostered ingenuity. Engineers devised ways to optimize fuel consumption, increase boiler efficiency, and strengthen frames without increasing weight. Each locomotive became a microcosm of wartime engineering strategy. By spring 1942, the first prototypes rolled out of Baldwin's factories. They were massive, powerful, and fast, a stark contrast to the aging engines still operating on other parts of the national network. Engineers ran repeated tests, measuring speed, torque, and endurance. Adjustments were made on the fly. Each iteration brought the locomotives closer to the ideal balance of speed, power, and reliability. These locomotives were more than machines. They symbolized America's industrial capability, the skill of its workforce, and the urgent necessity of innovation in wartime. They bridged the gap between civilian industry and military logistics, turning ordinary rail yards into hubs of strategic importance. Baldwin's role demonstrated that even in a nation without high-speed trains, ingenuity could accelerate progress when survival demanded it. As the nation's rail network strained under the weight of war, Baldwin Locomotive Works became the fulcrum of transformation. Its engines would not only move freight and troops faster, they would redefine the possibilities of American rail transport, laying the groundwork for innovations that would influence the post-war era. The stage was now set for the next chapter. The multiple angles from which this story could be told, technological breakthroughs, human labor, military strategy, and the broader impact on the war effort. The story of Baldwin Locomotive Works in 1942 is as much about people as it is about steel. On the technological front, engineers were grappling with problems that had no simple solutions. Steam locomotives had been refined over a century, yet the demands of wartime logistics pushed them beyond conventional limits. Standard freight engines were designed to haul heavy loads at moderate speeds. The War Department, however, required machines that could carry immense weight while maintaining velocity, sometimes over 70 miles per hour, speeds unheard of for engines of that size. To achieve this, Baldwin engineers turned to innovation. Boilers were enlarged and reinforced to handle higher pressure, increasing both power and efficiency. Drive rods and wheels were recalibrated for smoother motion at high speeds, while roller bearings replaced traditional journal boxes, reducing friction and wear. Suspension systems were redesigned to prevent oscillation on curves, a common cause of derailments at speed. Even the locomotive's aerodynamics were considered. Streamlined casings, though primarily cosmetic, reduced wind resistance and reflected the cultural fascination with speed sweeping across America. Each improvement was tested, measured, and adjusted, a meticulous process repeated countless times in the company's sprawling Philadelphia factory. But technology alone could not guarantee success. The human element was equally vital. Baldwin's machinists, engineers, and laborers worked long hours under immense pressure. Winter cold and steel noise were constant companions, yet morale remained high. There was a palpable sense of purpose. Every rivet driven, every boiler welded correctly meant faster transport for troops, more efficient movement of supplies, and, ultimately, lives saved. Engineers were celebrated for their problem solving, but it was the factory floor workers who bore the weight of innovation, translating blueprints into functioning, war-ready locomotives. Crew members who would eventually operate these engines faced their own challenges. Running a high-speed, fully loaded locomotive demanded a combination of skill, intuition, and physical endurance. Engineers had to maintain precise boiler pressure while anticipating track conditions and balancing load dynamics. Firemen, responsible for managing the coal and water supply, worked in sweltering heat inside the firebox while maintaining alertness for hours on end. Even minor mistakes could cause delays or accidents, making every crew member a critical part of the machine's performance. Technological innovation extended beyond speed and power. Baldwin's engineers also focused on durability and maintenance efficiency. Wartime conditions demanded locomotives that could operate for weeks without significant repair. Standard engines often required regular maintenance that slowed schedules and strained personnel. Baldwin introduced modular components and easier access panels for critical parts, allowing crews to conduct repairs quickly and keep trains moving. These incremental improvements were the difference between a supply line that faltered and one that ran like clockwork. The impact of these innovations was immediate and tangible. Trains once limited to 40 to 50 miles per hour were now sustaining 70 to 75 miles per hour under full load. Freight trains could carry more than 1,000 tons, cutting transit times dramatically. Ports that previously struggled with congestion suddenly received supplies at a pace that supported large-scale shipbuilding and troop deployment. Baldwin locomotives became the arteries of a wartime economy, moving food, ammunition, and machinery with unprecedented efficiency. Yet the human stories behind the machines added depth to the technological narrative. Workers' letters to family often spoke of pride and exhaustion, of the strange intimacy that developed between men and the engines they built. Engineers described the thrill of testing a new boiler design or watching a train accelerate under load for the first time. The camaraderie on the factory floor mirrored the larger sense of national purpose. In many ways, Baldwin's workforce embodied the war effort itself, tireless, disciplined, and driven by necessity. The combined human and technological efforts also reflected a larger cultural shift. In an era when speed and mechanization were celebrated, Baldwin's high-performance locomotives became symbols of American ingenuity. That it demonstrated that even a country without pre-existing high-speed rail could innovate rapidly when necessity demanded it. The locomotives were tangible evidence that the United States could adapt its industrial base to meet strategic challenges, a lesson that would reverberate long after the war. This perspective also illuminates the stakes of innovation. Each breakthrough in boiler design, suspension, or wheel alignment was not just an engineering accomplishment. It was a logistical advantage. Faster, more reliable trains meant that troops reached ports in time, that ammunition arrived before battles, and that industrial production flowed uninterrupted. Technology and human skill were inseparable, each amplifying the other. Baldwin's locomotives were machines, but they were animated by the expertise, endurance, and vision of the people who designed, built, and operated them. By examining these angles, the relentless pursuit of mechanical perfection and the dedication of those who made it possible, we begin to understand why Baldwin Locomotive Works became a cornerstone of America's wartime logistics. The engines were more than steel and steam. They were a convergence of knowledge, effort, and national purpose, capable of reshaping the very speed and efficiency of the United States war machine. And yet, technology and human effort alone did not tell the full story. The military strategies that leveraged these locomotives, the leadership decisions guiding their deployment, and the way enemies perceived this sudden surge in logistical capability would soon take the narrative to the next level. While Baldwin's engineers and workers labored to push locomotives to unprecedented speeds, military strategists were already calculating how to exploit this newfound capability. In 1942, the United States faced a logistical challenge of historic proportions. Millions of tons of equipment, supplies, and personnel had to move from inland factories to coastal ports, then across oceans to battlefields in Europe and the Pacific. The railways, once simply arteries of commerce, became critical instruments of national strategy. Military planners quickly realized that faster, more reliable trains could alter operational tempo. Troop deployments that once took days could now be accomplished in hours, allowing the War Department to concentrate forces efficiently. Ammunition and fuel could arrive ahead of planned offensives, reducing the risk of shortages during critical operations. Even subtle improvements, such as synchronized scheduling of multiple high-speed freight lines, allowed for near-continuous movement of war material without congesting yards. Baldwin's innovations were thus not merely mechanical triumphs. They were strategic enablers. Leadership decisions at both the federal and corporate level played a decisive role in this transformation. War Department officials coordinated closely with Baldwin executives to prioritize locomotive designs and production schedules. Every ton of steel, every boiler, every wheel had to be allocated with precision. Baldwin's president and chief engineers engaged in daily briefings, balancing technical feasibility with military urgency. Meanwhile, commanders in the field monitored rail progress closely, understanding that delays could compromise entire campaigns. The symbiosis of industrial leadership and military oversight exemplified the wartime ethos: collaboration and accountability under extreme pressure. Tactical considerations extended beyond simple speed. Planners had to consider rail gauge limitations, track capacity, and the resilience of lines under heavy loads. Engineers experimented with double-heading locomotives, attaching two engines to a single train to handle extreme tonnage. Signaling systems were upgraded to accommodate faster traffic, reducing the risk of collision. Even minor innovations in scheduling and logistics could yield significant operational advantages. A single locomotive reaching a port hours ahead of schedule could influence the timing of naval convoys or the embarkation of troops. The enemy, too, took notice. German intelligence was attentive to American industrial mobilization, though its focus was primarily on shipbuilding and aircraft production. Yet reports of Baldwin's high-capacity, high-speed locomotives suggested a country rapidly closing its technological gap in logistics. The ability to move vast quantities of material quickly raised concerns about the sustainability of any Axis strategy that relied on delaying or disrupting Allied supply lines. While the locomotives were not combat vehicles, their existence demonstrated an industrial agility that complicated enemy calculations. In the theater of global war, speed and reliability were as potent as firepower. The moral and societal dimensions of Baldwin's work also shaped tactical thinking. The dedication of American workers, engineers, and train crews became a form of soft power. Newspapers and radio reports highlighted the feats of Baldwin locomotives, portraying the company as a symbol of national resilience and ingenuity. Public confidence in the war effort grew alongside these technological advances. The very image of a massive locomotive racing across the countryside conveyed strength, purpose, and progress, reinforcing the psychological underpinnings of wartime mobilization. Leadership at Baldwin was acutely aware of the stakes. Delays in production or miscalculations in design could ripple across the entire military strategy. The company's executives navigated bureaucratic pressures, resource constraints, and the high expectations of both government and public. Decisions were measured and deliberate, yet informed by a keen sense of urgency. The relationship between industrial leadership and military command became a model of efficiency, highlighting how private enterprise and government objectives could align under extreme circumstances. In addition, the deployment of high-speed locomotives required coordinated training and operational planning. Military railroad units learned to operate these new engines under strict schedules, often in challenging weather conditions. Officers developed protocols for convoy movements, coordinating multiple trains simultaneously to maximize throughput. Tactical precision was critical. A mismanaged schedule could negate the technological advantages Baldwin had built into its locomotives. Ultimately, this angle reveals a layered reality. Baldwin's machines were more than technical marvels. They were instruments of strategy, shaped by human leadership, operational planning, and enemy perception. The high-speed locomotives symbolize the interplay between technology, command decisions, and national objectives. Their existence allowed the United States to mobilize faster, sustain longer, and act more decisively than would have been possible with conventional engines. By combining engineering brilliance with disciplined leadership, strategic foresight, and an understanding of the broader geopolitical context, Baldwin Locomotive Works helped reshape the tactical landscape of the war. Trains that once carried cargo at a leisurely pace now became engines of military efficiency, supporting operations thousands of miles from American factories. Every mile they traveled was a testament to planning, coordination, and ingenuity, a silent force contributing to the rhythm of global conflict. The convergence of human skill, mechanical innovation, and strategic leadership set the stage for what would become the decisive moments of the story. The technological breakthroughs and tactical implementations built momentum, preparing the rail network for its ultimate test, operational deployment under the full pressures of wartime logistics. By spring 1942, the first Baldwin high-speed locomotives rolled out of the Philadelphia factories. They were imposing machines, boilers the size of small rooms, wheels polished to a reflective sheen, and drive rods engineered for both power and precision. For the engineers, machinists, and military observers who had overseen their creation, these engines represented the culmination of months of painstaking labor. Yet the true test awaited: the open rails. The initial runs were both a technical trial and a psychological milestone. In March, prototype number 401, nicknamed Liberty, conducted its first loaded test between Harrisburg and Philadelphia. Fully loaded with freight, including ammunition crates and field equipment, the locomotive accelerated along the 45-mile stretch. Pressure gauges were monitored by engineers in real time, while firemen worked the boilers with practiced precision. The train reached sustained speeds of 72 miles per hour, a benchmark previously unattainable for engines carrying such weight. Minor adjustments were noted, small changes in valve timing and wheel lubrication, but the run was deemed a success. Following this, Baldwin implemented a series of rigorous trials across multiple terrains. The Allegheny Mountains tested the Engine's climbing power. Tracks along the Susquehanna River challenged suspension systems and braking efficiency. Coastal runs to Philadelphia's port facilities measured endurance and fuel consumption under long-haul conditions. Every mile provided data that was meticulously recorded. Engineers refined boiler pressure, optimized wheel alignment, and adjusted suspension damping to prevent oscillations at high speed. By mid-April, these locomotives could haul 1,200 tons of cargo at speeds that earlier engines could only dream of carrying without risk of derailment or mechanical failure. The human element remained critical during these early successes. Crews trained specifically for the Baldwin high-speed engines endured long shifts, learning to balance throttle control, steam pressure, and track conditions. Firemen worked in searing heat within the firebox while monitoring coal consumption, adjusting airflow to maintain optimal pressure. Engineers calculated curves, grades, and switching points, ensuring that the enormous machines remained stable at velocity. Their skill transformed raw technological potential into operational reality. The first operational deployment came in May 1942. Baldwin locomotives began moving war material from inland manufacturing hubs to East Coast ports. In one notable instance, a convoy of 3 high-speed freight trains carried artillery, tanks, and ammunition from Pittsburgh to Norfolk, Virginia. The journey, which had previously taken over 2 days with conventional engines, was completed in just under 36 hours. Soldiers awaiting embarkation for North Africa noted the unprecedented speed of the supply lines, a change that would affect operational planning across multiple theaters. Reports from military observers were immediate and emphatic. Colonel James R. Merritt, assigned to coordinate logistics at the Norfolk port, noted in his dispatches, "The Baldwin engines have exceeded expectations. Freight that once arrived piecemeal now reaches the docks in consolidated, timely shipments. Operational planning can proceed with confidence in the rail system." Such endorsements highlighted the strategic impact of these early successes. Baldwin had not only engineered a faster locomotive, it had altered the tempo of American military operations. The breakthrough was not without challenges. Tracks were sometimes ill-prepared for sustained high-speed runs. Switches and signal systems designed for slower freight traffic had to be upgraded. Minor mechanical failures occurred. Valve leaks, wheel misalignments, and occasional boiler pressure inconsistencies. Yet each setback was analyzed, corrected, and incorporated into the next iteration of the engines. By late May, Baldwin had refined production protocols to ensure that all subsequent locomotives met stringent performance criteria. These early successes also demonstrated the scalability of innovation. Baldwin's production lines, initially designed for incremental improvements to existing locomotives, were adapted to produce engines capable of handling heavier loads at unprecedented speeds. Collaboration with military logistics teams ensured that engine specifications aligned with operational requirements. The integration of engineering, production, and tactical deployment created a feedback loop. Lessons from the field informed factory adjustments, and factory advancements enhanced field capabilities. By June 1942, Baldwin high-speed locomotives were an operational reality. Trains traversed hundreds of miles with predictable speed and reliability. Freight that once trickled to ports and stages now moved in coordinated convoys, reducing congestion and ensuring the timely arrival of critical material. The War Department recognized the impact. Supply chains that had been vulnerable and unpredictable now gained consistency, enabling more confident planning for overseas operations. The early breakthroughs of Baldwin locomotives marked a decisive turning point. They proved that American industry, when pressed by necessity, could rapidly innovate, producing machines capable of reshaping the pace and efficiency of wartime logistics. Yet the story was far from over. The engine's full potential would be realized only when deployed at maximum scale, under the continuous strain of global war, a test that would push men, machines, and strategy to their limits. By mid-1942, Baldwin high-speed locomotives were no longer prototypes. They had become the backbone of American wartime logistics. Trains stretched across the nation, from the industrial heartland of the Midwest to the Atlantic and Gulf ports, carrying the weight of tanks, artillery, ammunition, and troops. Their arrival transformed not just schedules, but entire military strategies. In July 1942, a coordinated operation moved 3 fully loaded trains from Chicago to New York Harbor, a distance of over 800 miles. These trains carried mechanized equipment destined for shipment to the European theater. Each locomotive, operating at 70 to 75 miles per hour, maintained precise timing. Engineers and firemen worked in synchronized rotation, monitoring boiler pressure and wheel alignment, ensuring that the massive loads did not overstress tracks or cause delays. The operation concluded ahead of schedule, a testament to Baldwin's engineering and the crew's expertise. Military planners noted that such reliability allowed for coordinated amphibious training exercises on the East Coast, knowing that all material would arrive on time. The engine's impact was most pronounced in the movement of armored divisions. Previously, deploying a single tank brigade from the Midwest to a coastal port could take nearly a week. Baldwin locomotives have that time. The rapid transport allowed U.S. commanders to concentrate forces for the first North African operations, including Operation Torch later that year. Speed was no longer a convenience. It became a strategic advantage. Units could train, deploy, and redeploy with a confidence that reshaped planning at every level. Mechanical challenges persisted, but were met with ingenuity. Track maintenance crews worked tirelessly to reinforce lines, particularly along curves and gradients, where the heavier, faster engines exerted additional stress. Switches were upgraded to handle high-speed traffic, and signaling systems were modernized to reduce collision risk. Each improvement, though minor in isolation, collectively ensured the smooth operation of the growing fleet. Baldwin's engineers monitored performance data from the field, feeding adjustments back into production, creating a dynamic cycle of continuous enhancement. The trains also demonstrated their value under operational stress. In August 1942, a convoy transporting 1,500 tons of ammunition to Norfolk faced torrential rains. Tracks softened, slowing standard freight trains to a crawl. Baldwin locomotives, with reinforced suspension and carefully calibrated weight distribution, maintained operational speed delivering material on time. Military observers described the performance as remarkable, almost uncanny, noting that these engines reduced logistical delays that had previously hindered operations. Beyond raw performance, Baldwin locomotives enabled new logistical tactics. Engineers experimented with double heading, using two engines to pull exceptionally heavy trains, allowing longer convoys to move without increasing travel time. Crews coordinated closely with telegraph and telephone dispatchers to maintain precise intervals between convoys. The result was a near-continuous flow of supplies, troops, and equipment, a logistical rhythm previously unimaginable. Enemy intelligence, while primarily focused on production and naval movements, noted the speed and efficiency of U.S. supply lines. Reports indicated that German planners were aware of the rapid inland-to-port transportation, understanding that it increased the United States' ability to project force abroad. While Baldwin locomotives were not combat vehicles, their contribution was undeniable. Operational tempo increased, supply bottlenecks diminished, and strategic flexibility expanded. The human element remained central. Firemen, engineers, and brakemen adapted to the demands of sustained high-speed operation. Rotating shifts, rigorous maintenance, and precise coordination were essential. Letters from train crews spoke of exhaustion tempered by pride. "We move the war," one engineer wrote, "1 mile at a time, and every mile counts." The dedication of these men transformed mechanical potential into operational reality, their labor inseparable from the strategic gains achieved. By the end of 1942, Baldwin high-speed locomotives were moving over 100,000 tons of cargo weekly along critical routes. Freight yards that once backed up for days now processed shipments with efficiency that surprised even the most optimistic military planners. The combination of engineering, human skill, and leadership allowed the United States to sustain a war effort on multiple continents simultaneously, a feat made possible in part by machines born of necessity in Philadelphia. The peak operational impact of Baldwin locomotives demonstrated that innovation under pressure could redefine the boundaries of possibility. They were not merely engines. They were instruments of national strategy. Their speed, power, and reliability allowed planners to execute complex troop movements, coordinate supply convoys, and maintain a tempo that Axis forces struggled to match. As 1942 drew to a close, these locomotives had proven their worth. They had passed every test of endurance, performance, and reliability. Yet the story of their impact was only beginning. The success on domestic rails foreshadowed a broader transformation in the United States' approach to industrial mobilization, logistics, and technological adaptation. A transformation whose consequences would ripple into the post-war era. By early 1943, the effects of Baldwin Locomotive Works high-speed engines were unmistakable. Rail yards across the nation had been transformed. Tracks once congested with idle freight now hummed with continuous movement. Ports in Norfolk, Philadelphia, and New York saw the steady arrival of artillery, tanks, ammunition, and supplies. The War Department reported that shipments which had previously been delayed by days or even a week now reached their destinations on schedule, enabling more precise operational planning and deployment. The numbers spoke volumes. In the 6 months following full deployment, Baldwin locomotives were responsible for moving over 500,000 tons of military cargo along critical inland-to-port routes. Troop movements accelerated dramatically. Divisions could be concentrated at staging areas days ahead of anticipated schedules. Military planners noted that the reliability of rail transport allowed for overlapping operations, where multiple campaigns could be supported simultaneously, an outcome previously impossible with conventional locomotives. Military observers recognized Baldwin's contribution explicitly. Colonel James R. Merritt, overseeing logistics of the Norfolk port, reported, "The efficiency of supply lines has improved beyond expectation. The Baldwin locomotives have effectively redefined the rhythm of our operations, allowing for a tempo that enhances strategic flexibility." Other field officers echoed this sentiment, noting that the engine's speed and reliability directly influenced the timing of overseas deployments. Beyond the immediate logistical gains, the locomotives enhanced the morale of soldiers and workers alike. Soldiers embarking for training or deployment saw massive, gleaming engines hauling crucial equipment at unprecedented speed. Their confidence in the Army's ability to sustain operations was reinforced. Meanwhile, factory workers and machinists in Baldwin's Philadelphia plants understood that their efforts translated into tangible support for troops overseas. Letters home from employees described a sense of pride. "Every rivet, every weld, every mile these trains cover means our boys are one step closer to victory," one machinist wrote. Newspapers and trade publications began to highlight the achievements of Baldwin locomotives. Articles praised the engine's speed, durability, and contribution to the war effort. They were portrayed as symbols of industrial ingenuity and national resilience, demonstrating that America could rapidly adapt its infrastructure to meet the demands of a global conflict. Even the general public, previously unfamiliar with the intricacies of rail logistics, began to appreciate the strategic importance of these machines. Reports from the Office of Defense Transportation provided further validation. Efficiency metrics showed that routes served by Baldwin engines experienced fewer delays, reduced cargo damage, and higher throughput compared to conventional freight lines. Maintenance crews, initially skeptical of the heavier, faster engines, reported that improved designs, modular components, and accessible inspection points facilitated quicker repairs, keeping trains in operation longer. This created a feedback loop. Faster trains meant higher demand, which in turn justified further production and refinement. The immediate post-operation phase also revealed vulnerabilities. Tracks, particularly older segments, required reinforcement to withstand repeated high-speed loads. Bridges, switches, and signaling systems were upgraded nationwide to accommodate the locomotive's increased demands. Yet these challenges were manageable, and they spurred additional innovation. In effect, Baldwin's engines not only solved logistical problems, but also drove modernization of the rail infrastructure itself. In sum, the immediate aftermath of Baldwin's high-speed locomotives demonstrated measurable, transformative effects. Freight moved faster, troops deployed more efficiently, and supply chains gained unprecedented reliability. Military planning benefited directly from this new logistical rhythm, while morale and public perception reinforced the strategic value of industrial ingenuity. Baldwin's locomotives had fulfilled their initial promise. They were engines of war, productivity, and national confidence. The impact of Baldwin Locomotive Works' high-speed engines extended far beyond the immediate demands of wartime logistics. By the end of 1943, the locomotives had not only revolutionized supply lines, but had also left an enduring mark on America's rail industry, industrial planning, and technological imagination. One of the most visible consequences was the modernization of the nation's rail infrastructure. Tracks, bridges, and yards upgraded to accommodate Baldwin's heavier and faster engines remained in use long after the war. Switches were reinforced, signaling systems improved, and double-track routes became standard along critical corridors. Rail companies, recognizing the operational advantages, invested in permanent improvements. Baldwin's innovations had indirectly catalyzed a nationwide modernization effort, elevating the efficiency of freight transport for decades to come. The locomotives also influenced post-war design thinking. Engineers who had worked on the high-speed wartime engines applied lessons learned to peacetime projects. Boiler efficiency, wheel alignment, suspension technology, and streamlined bodywork informed the next generation of locomotives, including diesel-electric hybrids that would define post-war rail travel. Baldwin's work demonstrated that constraints, wartime necessity, resource scarcity, and performance demands could drive technological leaps that shaped entire industries. Industrial strategy benefited as well. Baldwin's collaboration with the War Department became a model for public-private partnership, showing how government requirements could be met through efficient coordination with private enterprise. The lessons were applied in subsequent mobilizations and infrastructure projects, from highway construction to airfield expansion. Wartime urgency had proven that accelerated production and innovation were achievable when industry and government aligned toward a common goal. Beyond technology and logistics, Baldwin's high-speed locomotives left a cultural and psychological legacy. They became symbols of American ingenuity, industrial skill, and resilience. Wartime propaganda highlighted these trains as embodiments of national strength, connecting factory floors to battlefields in the public imagination. For workers and engineers, they represented a tangible contribution to victory, a reminder that technological skill and human labor could directly influence the course of global events. The locomotive's performance also influenced military planning in the post-war years. Strategists recognized that mobility, speed, and logistics were as decisive as firepower. The lessons learned from Baldwin's high-speed engines informed post-war deployment strategies, including rapid troop movements and the logistical frameworks for U.S. occupation forces in Europe and Asia. The notion that efficient transport could shape operational outcomes became a permanent element of military doctrine. Internationally, Baldwin's success resonated as well. Allied nations studied the high-speed engines, adapting aspects of their design and operational protocols. The United States had demonstrated that a nation without pre-existing high-speed rail infrastructure could innovate rapidly under pressure, setting a precedent for post-war rail projects worldwide. Baldwin's locomotives became a benchmark, not only for speed and reliability, but also for industrial problem-solving under extreme constraints. Perhaps most importantly, Baldwin's wartime innovations highlighted the inseparable relationship between technology and human skill. Engineers, machinists, firemen, and crews had collaborated under intense pressure, proving that even the most advanced machines depended on human expertise for success. This lesson informed post-war industrial training programs, emphasizing practical experience alongside theoretical knowledge. By the late 1940s, the era of Baldwin's high-speed steam locomotives was giving way to diesel-electric engines, faster and more efficient for peacetime commerce. Yet the legacy endured. Tracks strengthened for wartime use, engineering innovations, and the integration of industrial production with strategic planning remained a foundation for America's mid-century rail and transport systems. Baldwin's wartime engines had not only served their immediate purpose, but had reshaped expectations for speed, reliability, and industrial capability. The long-term consequences, therefore, were multifaceted. Infrastructure modernization, technological advancement, industrial strategy refinement, cultural symbolism, military doctrine, and international influence. Baldwin Locomotive Works had done more than move cargo at unprecedented speed. It had transformed how a nation thought about industrial capacity, logistics, and the power of innovation in the service of national objectives. These outcomes naturally lead to reflection. The calm, measured evaluation of what Baldwin's high-speed locomotives meant for history, humanity, and the enduring lessons of necessity-driven innovation. The story of Baldwin Locomotive Works in 1942 is more than a tale of steel and steam. It is a story of necessity meeting ingenuity, of human skill amplified by technological innovation. In a nation without high-speed trains, Baldwin's engineers and workers transformed American railways into arteries capable of sustaining a global war effort. They demonstrated that constraints, time, resources, and wartime urgency could catalyze progress in ways that peacetime conditions rarely demanded. The locomotives themselves were remarkable, but their true significance lay in the convergence of human and machine. Engineers calculated every pressure gauge and wheel alignment. Machinists executed each task with precision. Firemen and crew translated design into motion across hundreds of miles of track. Together, they formed a living system where human expertise and industrial technology were inseparable. The success of these trains was a reflection of discipline, collaboration, and the shared understanding that each mile covered had consequences far beyond the rail yard. In a broader sense, Baldwin's innovation highlights a timeless truth: war accelerates change. The locomotives reshaped logistics, influenced military strategy, and left an enduring mark on industrial design. They modernized infrastructure, set standards for efficiency, and demonstrated that even a country starting without high-speed rail could rapidly achieve what once seemed impossible. The lessons learned extended into the post-war era, shaping both American transportation and approaches to industrial mobilization. But there's also a human resonance. These machines carried more than cargo. They carried the hopes, fears, and determination of a nation at war. Soldiers, civilians, engineers, and laborers all depended on their reliability. Each journey was a quiet testament to ingenuity under pressure, to the value of coordinated effort, and to the tangible impact that dedicated individuals could have on history. Ultimately, the Baldwin high-speed locomotives remind us that innovation is never just technical. It is human. Their legacy endures not only in rail lines and engineering manuals, but in the enduring example of what a nation can achieve when necessity, skill, and purpose converge. The rails they once dominated may now be quieter, the steam long replaced by diesel and electricity, but the story of their creation remains a powerful lesson in speed, precision, and human ingenuity.